From Anaheim, California, this is the Decode Podcast. In the Apex 2026 recording booth, we're joined by Mr. Declan from Watt. And Declan's requested that we subtitle this because English is not his first language. But I kid, it's not that thick. Welcome aboard, Declan.
Thank you. Happy to be here.
So, Declan, you are the lead engineer at Watt, and Watt is a relatively young company in the laser manufacturing space with an emphasis on, I'm going to be happy this episode, on stencil production, right? So tell us a little bit about the history of Watt, how you came together, and pretty unique, making things in the UK. Talk to us.
So founded by Fraser Shaw, I think was on the podcast last year, and Pete Rivet, who had some history with Tanlin in terms of making stencil cutting systems. So they came out of Tanlin and kind of during COVID started up Watt Laser. I then joined. I graduated out of university.
It's only a few years old, you're saying?
Yeah. So it was my first job. I had a job lined up in the oil and gas sector. Hiring freeze went on because of COVID. So I was sitting around with nothing to do. Fraser called, needed some 3D CAD work done. Started there, and then over the past 5-6 years, it's just kind of spiraled into where we are now. So big focus on stencil manufacturing, trying to do new things, trying to do things a little bit differently, but kind of keeping the fundamentals of ease of use and innovation.
Yeah, so my first foray into using any of Watt's equipment was our SC12 Pro.
Yeah. Which
is I joke around kiddingly sometimes.
QC tool.
Well, I kiddingly say sometimes it almost does too many things. We've used the term Swiss Army knife already a couple times today, but it does a number of things. One, and I think my primary interest in the platform was it does stencil AOI.
Yep.
Right. So it actually will perform an entire scan, 100% aperture check for presence, size, position, and it does a fantastic job of that. It also, after the inspection, will go through and do kind of a detailed measurement, and it's truly a piece of metrology equipment, right? I mean, it's got micron scales on it, and it's very good at that. But it also it's got a laser mounted on it too, right? So now we can mark foils, right? We can do laser marking, modify the surface of the foil. And because it has a laser, it'll also do welding. So you can see why it's for a stencil maker, it's such a cool little toolbox. Yeah. Takes up a small footprint. It's amazing. I can't imagine life without it now.
It's the perfect companion to your cutting system. You know, at the end of the day, the cutting systems are designed to cut. You know, if you gave anyone in our industry a blank piece of paper to design a welding machine or an inspection machine or even a marking machine, they wouldn't design a cutting machine.
It's a terrible platform for it.
Yeah,
for all those functions.
Yeah, and it's a convenience thing. You know, it was right. You got to buy a cutter to be a stencil manufacturer. Can we make it weld? Can we mark on it as well? So it's kind of a necessity thing, but it's just not designed for it. And at the end of the day, if your cutter's spending time doing something else, it's not cutting, and it's not making you money. So it's taking all those off of the cutting system just makes complete sense.
Right, because those other functions are not value adds, right? I mean, marking identification on a stencil makes you $0.
Yeah.
Inspecting the stencil makes you $0.
Yeah.
Arguably, welding was the only function that had a value add, but stencil cutting lasers are piss poor at welding.
Yeah.
Just the reality.
Yeah.
So, fast forward, we've had maybe about a year and a half under our belt with the SC12 Pro.
Yeah.
But now Watt has a stencil laser offering that I'm very excited to put my hands on soon. But talk to us about Nevis.
Yeah. So, I mean, we had the previous cutting system, and it's okay. It does a job, and it was absolutely by industry standards was up there. But we started using the Aerotech motion control on one of our custom systems, which was so it was for the automotive sector for one of the Formula One teams, and we worked on that, and there was some problems at the start, but we've kind of developed it a little bit alongside Aerotech and spent a lot of time on it, and kind of reached a point that, right, okay, this is worth putting in a stencil system. Now, it's expensive. The Aerotech stuff is expensive, but it's the best on the market. So, yeah, we've reached the point that makes sense to put in a stencil cutter. There's a few other changes alongside it. We changed the head design. We brought the spot size down to kind of around about 16, 17 microns, which for the kind of the newer stencils and the thinner material, it just buys you so much capability.
What would be the next? By the way, I'm loving this part because whenever I have like a PCB guy on, I always talk for a really long time, and he always gives me a hard. And like I was watching the thing, I'm like 4 minutes and 30 seconds, and I was loving every minute of it. Just to be like, you know what? This is what. What's the matter? You want to talk about the things you love? Oh, sorry. But anyways, I was thinking because you mentioned all of these different like additives that this machine can do, right? The only thing I think that we would be missing would be the nanocoat side of it. Is there a future where you're adding that to it too, or?
Yeah, you can get yourself into trouble if you try and combine, wet and dry processes. In terms of, where the SE12 started, it was around the surface preparation for nanoslick coating to help with adhesion.
Really, like rough it up a little bit?
Yeah, it's a really precise, kind of repeatable sanding. If you're gluing, bonding two things together, you're going to sand it up.
Yeah.
It's kind of like that, but in a really repeatable way.
Wow.
Yeah.
And then it just evolved into, well, I guess we could write on it with this, right? Yeah. I love your stencils, you know that. But you knew what I used to get before I got from you, so I mean, the bar was set really, really right.
Stepped right over.
Right. It wasn't too hard, but I mean, they look like flawless. You know what I'm saying? There's like none of that.
Yeah.
Right. Like
yeah.
it's just not there.
Yeah.
And what I really love about it, from like a personal, is like my old printer. It was a top-down camera, so the fids were on the top of the stencil,
yeah.
right? And now I can send this stencil to him, and he can just put the new fids on the bottom, right? Good to go.
And do even better than that. We put them on both sides all along.
I know.
Forward thinking.
I know.
One of the things I enjoy about working with Watt is the size of the company and the youth that's involved in the company. There's a lot of creativity and innovation that goes in, and you can really see it in the user interface, right?
Yeah.
There's some really cool Easter eggs in there, and kind of the focus on connectivity. And I've been working on an ERP, homegrown, and I can't wait to start getting some of those integrations with, with the SE12 Pro and with Nevis, so that info's feeding forward and backwards.
Yeah, I mean, it's something that's done reasonably well in the EMS industry, but in my experience in the stencil manufacturing side, it's not really done, which doesn't really make sense. But yeah, on the software, our software guys are the best in the industry. They're always pushing new things forward. They're trying new things, and it's all kind of aimed at making the operator's life as easy as possible. Selling these SE12s, I was going out next to a wide range of cutting systems. Some with good software, some with more difficult software. And it's always been our mantra and our focus is, reduce the button clicks. But if there has to be button clicks, make them easy and make them obvious what you're going to do. So like following the green button, in our systems, if you're going through a process, the green button's always going to kind of guide you through it.
If you have a 16 micron spot size, what does that mean your minimum repeatable, good quality aperture can be?
Yeah, so you can get down to kind of 60 to 70 microns. The coolest thing that we're seeing on Nevis is the interspacing. So because the way the controller works is we're controlling the kind of the laser energy going into the stencil, and you'll know as well as anyone, any laser process, you're always fighting against thermal effects. So, I mean, if you're able to control that energy more precisely, you can get your apertures that much closer together, which is
without any thermal distortion happening.
Exactly.
Yeah.
So that's the real challenge, I think, in the stencil industry just now. And got a couple of products that are kind of focused on, tackling that challenge.
Yeah, everything's getting smaller. So yeah, that 20 microns, 22 microns for a spot size was pretty good for a long time.
Yeah.
We used to say we can cut smaller than you can print. We're eating those words now. But yeah, just one other thing on the kind of support side. Like my operator has credentials, right, with Watt, and they can literally go in there and say, hey, it'd be nice if I could do this, and then like 2 days later we'll get like a system update, and that it would be nice features in the new release. I mean, how often do you get to do that? So that's amazing.
Yeah, and that's the kind of touching on the culture thing that you saw when you came over. It's we like new ideas and we like doing cool things. So if someone comes with an idea and it's going to benefit, the machine, the process, all of our customer base, then why wouldn't we do it?
Not all manufacturers are like that, though. I know I've shared what I thought would be helpful feedback to, equipment manufacturers before. They don't always love it.
We have a saying here in America, if your pick and place, for example, like places the component off center or your reflow profile was wrong,
It's a stencil.
you blame the stencil, right?
Yeah.
So do we blame the stencil equipment or do we blame the stencil manufacturer?
So the root all comes back to me.
Well, that's what I'm asking.
If you blame me,
that's
I'm
what
gonna
I'm
blame
asking.
him.
Right? Yeah. Right? So, but
No, it is a thing though. The stencil, it's the first thing on the line for most.
somebody
processes.
said today, if you don't have a good print, it's not going to go well from there, right?
Yeah.
So, but what does all of this do as far as like the stencils I receive, right? Because I don't know all this stuff, right? Like this is a lot of the what, right? Like what does it do? What does it? But why does this make it better from the stencils that I receive? Is this going to give me a better release? Is this going to get like I don't really understand about like the thermal of closeness of pads and stuff like that and how it affects because I never see it, right? I just get to blame him when the SPI comes bad, right? So I was just kind of curious, what does that do as far as what I get at the end product?
Yeah, it's what your technical challenges are really at the end of the day. If you want to print closer together and you can't just now because you can't get the stencil, then it's going to help you in that sense. Beyond that, yeah, you're going to get some better release if you get a good stencil, but that's up to this guy.
Yeah.
Yeah, I mean, when you talk about transfer efficiency and area ratio and all those factors that we know affect how well a stencil will print, I mean, the wall quality is paramount, right?
Yeah, you've shared pictures before.
Yeah, and they have a very nice microscope out there in Scotland, and I was able to kind of look at some of the cuts underneath there, and it's amazing. I always say if you use high enough magnification, you can make anything look bad, but it held up to some pretty high magnification.
Yeah. There you go.
I was just going to make a quick... We have a friend, we won't mention his name, but we have a friend that's Scottish, and we like to poke fun at him sometimes because everything in his mind is a fine Scottish invention. So we'll just put it on record that the stencil laser is a fine Scottish invention.
Well, it's not in his mind, it's true.
It is true.
It is true.
It is true.
It may actually be true when it comes to the stencil laser, right?
Yeah. No, I mean, Fraser's one of the early pioneers of it. And he's still, to be honest, the kind of the know-it-all in the industry. He's the one that people turn to.
He tells stories about taking like a photo plotter, right? I mean, like you would have used in board fab and strapping a cutting laser to it, and that kind of being the first stencil cutting system.
Yeah.
So. Shit. It just blew his mind so much that he lost. Before this ends, we have to talk about Nevis.
Yeah.
We
MLAb.
already talked about Nevis. MLAb.
Yeah. MLAB's the future, I think. Certainly for the packaging stencils, anything
That cold ablation.
Yeah, exactly. Anything sort of 3 mil and below, that's the sweet spot for it. Seen a lot of traction over in Taiwan. It's going to build as the E-form killer, essentially. We want to take over that sort of industry, that market. The really high precision, high aperture count, semiconductor packaging stencils. It's next level stuff.
The speed and the precision and the sizes that are, 40 microns, 50 microns?
Yeah, and we're pushing that. So there's there's a few different techniques you can use. We're starting to use laser drilling some more, so you can get down to sort of 15 to 18. That's still in development. And there's certain applications where it makes sense and certain applications it doesn't. But yeah, that's what we've really been pushing. In terms of the aperture sidewall, it's insane.
Zero slack. Completely smooth.
It's been a tough sort of process of education, because, everyone thinks laser cutting and they think of, Nevis and the traditional fusion cutting. MLAb's just completely different. It's using a ultra short pulse laser, and yeah, it's more at the micro machining level than it is at the stencil cutting level.
What would happen if you put your finger under it?
Nothing, but I'm not going to try it.
I tried to get him to cook chicken wings on there one time.
We tried to make toast once. It didn't work out, but no.
Did you crank up the power?
Yeah, we cranked it up, but yeah, it was still just bread.
They didn't think of that.
Did you eat it?
No.
Okay.
I wasn't brave enough.
All right. I don't blame you. I wouldn't either.
Yeah, I think that MLab's a little ahead of its time, and again, the educational portion of it. I've talked about it several times, and it catches people's curiosity, but then kind of making that use case argument, right?
Yeah.
Like when is this a benefit, right? And we're seeing smaller and smaller and smaller components, so fusion cutting is bouncing against the wall of what's possible now, right? And the assist gas has a big part of that, right? You could put apertures super close together. Maybe they survive the actual mechanically they're sound enough for that material to hold 15 micron space, but then you're blowing 12 bars of assist gas through. Bye.
Yeah, just goes off like a fuse essentially.
Yeah, and there's no assist gas used in the MLAb process. So
what's the con? Is it just the price?
The price, and the thickness. It's a different market from your kind of standard SMT stencils. It's more in the semiconductor space, the packaging space, which, yeah, as you say, it's a challenge to kind of change that mindset. And most people are importing those kind of stencils from Japan. They're the best.
You look at what yield cost of failure in those processes, right? I mean, it's a high entry point to get a system like that for sure, but what is the day in, day out cost of not having it if it's leading to decreased yields on products that are that expensive?
Yeah, and that's the thing, is lead time's such a big issue for these guys as well, and they're having to import stencils from Japan right now for the really fine stuff. So yeah, we're trying to give an option that you don't need to do that. You can use a laser process, which is much more repeatable than an E-form process. Yeah. That's why they're going to Japan, because Japan are experts in the E-form process. But we're saying do it on a laser. It's more repeatable. It's easier to use. It's cleaner. You don't have all those sort of nasty chemicals. And it's just a better process.
And it's incredibly fast for what it is. I mean, the stencil aperture counts are, right? I mean, we see 100,000. You start looking at some of the wafer level stuff, right?
Yeah.
Because it's a scanner-based system, it cuts so fast.
Yeah, it's completely different to the kind of standard cutting system. So,
can I get my standard stencil cut on that?
I wouldn't recommend it.
Why not?
It's just not the right technology for that product.
Really?
Well, it has a thickness maximum, right? It can only cut up to
3 mil.
3 mil.
3 mil.
Well, I want a 3 mil and a 2 mil stacked together, and then I get my 5 mil.
Well, it's a pretty simple principle, though, right? You're not going to put a 40 micron aperture on 4 mil foil. So, in the cases where you need MLAb, you're going to be in the thin foil. We had a guest on earlier from Innovax, and they were talking about their kind of smart stencil storage and how it tracks the amount of print. So we started along the lines of stencil life management, right?
Yeah.
Stencil lifecycle management. So the little brother to our SC12 Pro is the QC100, right? Which is basically the same platform but minus the laser. So you're not welding, you're not marking. Talk about how that could be a useful tool for contract manufacturers that are actually running SMT lines like these guys.
Yeah, so as we touched on earlier, the stencil's the thing at the front of the line, and if it's not right or if there's something wrong with it, you can't really continue the rest of the process. So what we're saying is, right, check your stencils, check them more often, have a machine that does it, and you can rule out that sort of early failure. We're checking for, make sure that this guy's cut the holes in the right place, and they're the right size. But we're also checking, post-cleaning, making sure all the solder is out of there. Also tracking the life cycle. So we're building up the history of this stencil's life, and we're tracking how the positions of the apertures move as there's any loss in tension.
Wow.
Catching any, damage that's causing, warpage in the stencil. And we're just saying, check them. For all it's going to cost you, it's going to save you a lot of headaches.
Or I could buy stencils from a guy that uses it, right?
Sure, and look, I'll push back and say that the initial quality of the stencil, that's our responsibility as stencil manufacturers, right? We need to guarantee and certify that it gets to your facility, all the apertures that are supposed to be there, none that aren't.
I thought I got them the other week.
Everything in the same place, but what Declan's talking about is monitoring the stencil over its life, right? People think, well, it's metal, so it's going to stay what it's going to stay, but the apertures can grow in size after repeated, solder paste deposit. Plastic deformation's a thing, right? So now you can start to change the positional values of the apertures. So monitoring that stencil throughout its life and finding at point where it no longer becomes a viable tool on your line, and then calling your provider and getting a replacement.
I thought I got them the other day. Yeah. There was like a bunch of non-pops on an array.
Yeah.
And then we threw it through the SBI, and it was flagging these as no paste. And I'm like, what's going on? So I'm wiping the stencil, cleaning this and that. And then we noticed that they weren't cut out.
Right.
So and I've just let him have it, right?
But did you see how much confidence I had?
And then the worst part was he pulls up the paste file I sent them, and they're not there.
I was like, no, because I know that I've got the watchdog at the door.
Right. I thought I had him dead to rights. So I was like, I want a new one on my desk, and I didn't really need it because it was a non-pop. I just wanted to mess with him.
Yeah.
I couldn't. Yeah, he was not rattled at all.
No, it's good to hear that it's actually. It's good to hear these stories that your confidence is there because the machine's in. So, no, it's nice to hear. But the other thing for the QC100 for yourself is actually analysing the PCBs themselves. So, checking the positional shift, the scale and the skew on the board.
Oh, is this the one that was for the stretch?
Yeah.
Oh, okay. Yeah, he was telling me about that.
Not only
insane.
does it check, it'll fix it.
Yeah, that's the crazy part.
It'll spit out a paste file that's adjusted to the actual conditions of your board.
That's useful.
Yeah. I mean, you can do it kind of in a batch. If you've got scan like 20 boards, then it'll kind of average your sort of your shift, so you can have the stencil that kind of matches that batch almost perfectly. And then the kind of newest feature is the reverse engineering. So you're basically just defining an area of where the board is, and it'll go and it'll pick up all the copper areas.
You've got no paste file. A customer brought some legacy boards. Here's the boards. Here's the parts. I don't have any data.
Yeah.
And then you could take that and make Centroid for your placement platform.
Wow. Fancy.
Well, I could talk to you all day,
I know.
These guys are going to, Sean's already looking at me like, you do this to me.
It's not that. I just want to find some way to blame him, and I can't yet.
Yeah.
I was actually thinking, like, I want you to remote into his PC and change the files so that way it shows they should have been there, right?
Yeah, but then he's just going to call me and say your machine didn't work.
Yeah. Oh, if people want to get in touch with you, Declan, see what's going on at Watt, some of the new offerings, what's the best way to do that?
Through our website, watt-laser.com, or just reach out, LinkedIn, anything. WhatsApp if you have my number, but anyway, I'll respond.
Awesome. Well, thanks for joining us, Declan, and
all right.
Thanks for watching.
Thanks, guys.